did life on Earth first get started? Is there life on other planets? What about planets that are thought not to harbor life? Is it possible that life could be just booting up as we speak? My name is Engelhart. I'm an assistant professor at the University of Minnesota in the Department of Genetics, Cell Biology, and Development. And these are some of the questions that my lab studies. Today I'm going to talk about the possibility of life on Mars. Past, present, or future. What we've learned and where we're going. So I'll start the story with the Viking missions that NASA launched in the 1970s. What you see on the screen is the first spacecraft that we landed on the surface of Mars. We launched these along with some orbiters that took the first photographs of the surface from Mars. And from these, we got quite a bit of information, some good and some bad, about the possibility of life on Mars. So this is a photograph from one of these orbiters. And what we learned from this was, of course, that there aren't little green men on Mars. It looks like life, if it is present on Mars, is microscopic. So as part of these missions, NASA did a number of experiments to test for the presence of microbes on Mars. They got some positive results and some negative results, but overall, the suite of experiments was regarded as inconclusive. However, there was some good news. From the photographs that we saw, it looked like the Martian surface had been profoundly shaped by water. Zooming in, you can see that there's evidence on the surface of what looked like dried up lakes, rivers, and streams. Water is especially important for the emergence of life because it's really what life is made of. Your cells, mine, and those of essentially every living thing are made of about 70% water. Water is so essential to life that NASA describes in its goals for finding life on other planets, framing it as follow the water. In 2004, NASA launched a pair of rovers that went to different parts of Mars. These were called Spirit and Opportunity. There really wasn't any bad news here. Spirit and Opportunity were intended to last 3 months each. They lasted years. Opportunity just shut down earlier this year. Opportunity traveled a distance greater than a marathon. If you look at that photograph, you can see it was traveling on what are essentially tank treads. From these missions, we learned quite a bit about Martian geology and how it compares to that of Earth. It turns out in many ways it's quite similar. And from these missions, we've developed simulants that we can use in labs on Earth to study how the surface of Mars might interact with different chemicals. In 2008, a mission called the Phoenix discovered a chemical that fundamentally changed the way that we view the search for life on Mars. Another rover, Curiosity, later found this chemical on another part of Mars, suggesting it might be found globally. This chemical is called perchlorate, and once again, it's kind of a good news, bad news story. First of all, perchlorate's toxic. In humans, it poisons our thyroid gland. Most microbes can't grow in the presence of it, but there are some hardy bugs that can handle it. In fact, they can actually use it as a resource. They can breathe perchlorate in much the same way that they breathe oxygen. In so-so news, the perchlorate seems like it might provide an explanation for some of what seemed like negative results from the Viking mission. One of the experiments that they did to look for life on Mars was to scoop up some of the surface material on Mars and heat it up and look for organic compounds, which would have been regarded as potential evidence for life existing on Mars. They didn't find much in the way of organic compounds, but now in light of what we've seen, there might be an explanation for this that doesn't rule out life. Perchlorate, when you heat it up in the presence of these compounds, degrades it. Now that we know there's perchlorate on Mars, this could explain this result. So moving on to the good news. Perchlorate, when you heat it up, generates oxygen. If you did fly here on a plane, above your head was an oxygen generator. And that oxygen generator contained a canister that contained a number of chemicals, including perchlorate and some related compounds. If something did go wrong on your plane and those oxygen masks came down, that canister would be heated up, and that's how the oxygen that you would breathe would be generated. If we were to ever decide to solve the problem of life on Mars by just going ourselves, perchlorate could be a powerful natural resource in this regard. In addition, it can act as a fuel. Perchlorate actually composed part of the fuel that was used to launch the space shuttle. In this regard, it could be a great natural resource as well. And then finally, and perhaps most importantly, perchlorate loves water. If you take a perchlorate compound and we weigh it out in the lab, it really doesn't look like much. Most of these look like table salt. They're white powders. But if you leave it out and you walk away for a few hours and you come back, you're likely to find a puddle. And that's because perchlorate loves water. What it's doing is sucking water out of the atmosphere and forming a salty brine. A number of investigators have found evidence that on Mars, perchlorates are actually soaking up water, potentially forming brines that could support microbes or the emergence of new life. So what's next in the search for life on Mars? 2020 is potentially going to be the most exciting year ever in the search for Martian life. There are 3 missions launching, one from the US, one from Europe, and one from China. For the first time as part of these missions, we're going to be able to explore the Martian subsurface. And this is particularly exciting because it's possible that just like on Earth, there's fresh water that exists beneath the surface. This could be potentially a great piece of news for the emergence of life because fresh water could be an even more hospitable environment for life than the salty brines I mentioned. Beyond this, we're going to collect samples for future sample return missions from Mars. And so why is sample return so important? All the experiments and results that I just described to you were obtained from spacecraft that we launched from Earth, slingshotted through Earth's gravity, then slingshotted through Mars's gravity, and landed on Mars. This is an 8-month journey that covers about 350 million miles. Because of this, we're kind of limited in what kind of instrumentation that we can take. As you can imagine, this kind of cramps our style scientifically. We can solve this problem with sample return. By taking samples from Mars, sending them back to Earth, and analyzing them in our laboratories on Earth, we're going to be able to learn more than we ever have about whether life exists, ever existed, or is currently emerging on Mars. Thank you.